and even though I like made a stupid mistake on the last quiz, I was like, oh, yes. Anyways, we're not gonna talk about it because I'm gonna get a 100 on this quiz, so it's not even gonna matter. Or is it 4? It's 4. Do what? I bet you did. I think that's what I. Well, see, that's the right answer. The last time I plugged in stupidly, I plugged in 5 for Q on X squared plus 1. So it was like 926. And I was like, you know what? It doesn't even matter. Okay. It didn't matter. Yeah, that's what I was going to say. I was like, my sister knows what. You're like, no! I was thinking something. You're. Okay, so. Cosine equals
You shouldn't think of it like that.
How should I think of it?
Well, it depends on if you're talking about derivatives or integrals.
Well, right, but like, if I can just think of it as like, as that, then I just, yeah. It's the same thing, just opposite. I feel like. Is there a secret rectangle? Do what? Just in case there's a secret rectangle. Is there a secret rectangle? Oh, no, I can't have those on the side. Okay, I can I figured it out. Do you nervous? Yeah, no, it's. Yeah, what's your start? Do you have next to how it's supposed to
Mr. Townsend, the number 73, I turned it in yesterday during study hall, like at like 12:59 or something. So I think you probably just didn't look at it in like the 6 minutes between when I turned it in and when it was due.
73?
73, the FRQs.
Oh, okay, yeah.
Yeah, so I got a 0, but I turned them all in. I did them all. So
I'll double check.
thank you.
You might remind me again, though.
Okay.
And sine equals cosine, and cosine equals negative sine.
So if I right, memorize answers.
I just don't like the way y'all say that. They're not equal.
No, but they like.
The derivative of one might be equal to the other, but it may not, integrating one may not be the other. It depends on which direction you're going.
But if you're going backwards, like negative sine would equal cosine.
It's like saying 3 is equal to 5 or something. It's like,
It's just how we put it.
or saying 3 and 5 is 8. It's like, well, yeah, if you're adding, but what if you're subtracting?
Where does the 4 go?
The direction matters.
Well, if we're going, if there's a right side equals cosine.
All right, we're gonna start off with our 2-question quiz here. So I need y'all to clear off your desk, please. No calculator.
Oh. See, I don't know if I don't think that morning. Yeah, I woke up 27.
Remember, take the U out. Put the Rachel back on. Okay, last time they were 2 points total, so I couldn't give partial credit there. Either right or wrong, but these are 2 points today, 2 points each, 4 points total. So I can give some partial credit if you get at least half of it correct. So one careless small mistake should only take off a point and not a whole point, or not 12 points. Wait, is that the wrong one?
No, this is good.
And before you guys get too deep into this, let me go ahead and remind you about the ACTM. If you're interested in doing that, I think, isn't Mu Alpha Theta like giving you an hour or something for doing that?
Yeah. Mm-hmm.
Okay. Just make sure that you know that the fee is $5, and I need that next week at the latest. There's a process where I have to get it to somebody on campus, and then they have to turn it into the district, and then they turn that into a check, and then we send that to the university. So I saw some of you are signed up for it, and that is great. But if you don't give me your $5 by next week, then it won't actually be registered. And there's nothing I can do to squeeze you in after that. It'll be out of my hands. For those of you that are finished, you might want to look over your review. Unless you have finished that, you might be able to do a couple more questions while we give everybody time. I want to make sure I'm not rushing anybody here.
I have extra. Because I printed it out and I can do this.
Still working, that is fine, but you do need to wrap it up here in just a second. Maybe one more minute, turn it into the basket, please. But for the rest of us, let's go ahead and move on. So I already gave you the ACT reminder. We've got a short little handout today, and then I want to get you back your most recent quiz. As I've been saying, your next test is over all of Chapter 5, which basically is the stuff from the last quiz, plus a couple other things, the main one being use substitution. So, anything that you missed last time, it could benefit you on your next assessment. Okay, honestly, this short little handout here, we're not going to actually integrate all these, but I just want to make sure that you guys are comfortable with logarithmic integration. I've already told you the basics that you need with this, but just kind of breaking it up into parts. So, the thing that you need to remember here is like what we did last semester. If we took the derivative of natural log, what did that give us?
1 over x.
Okay, and then I know I told you this one, but I don't know that we've used it much. If you integrate 1 over x, what does that give you?
absolute value of natural log.
Natural log of absolute value and a plus c. So when you're going this direction, we need the absolute value sign. So from last semester, and then this is one of the few that doesn't just, it's not exactly the same thing when you go the other direction. You need the absolute value sign. Okay, so again, I think we just haven't practiced it much, but on question 1, this is 5 times bigger than integrating 1 over x. So I know that constant sometimes throws y'all off, but if it's 5 times bigger, it means the derivative would be 5 times bigger, and if you're undoing the derivative, it's 5 times bigger. But this would be 5 natural log absolute value of x plus c. But also, if you've got more stuff under your fraction bar than just an x, it could still be natural log. Natural log is a way to make it all move to the denominator. Like, if you don't see that right away and you think this is u substitution, go for it. U substitution is not going to do anything here. There are questions that u substitution cannot do. But this one, if I want all of this, then I can just say the natural log of the absolute value of all of that. Now remember, we're just doing the antiderivative. So if you're willing to take the derivative of this and see that it goes back to 1 over x plus 1, that's a quick little check. So it doesn't just have to be an x in the denominator, it can be more than just an x. But because this one doesn't have chain rule, we don't have to do anything else with it. Okay, also in question 3, sometimes it makes sense to, you could try to do u substitution here and maybe it would work, I don't know. But honestly, before I would do u substitution, I would try to do things like exponent rules, fraction tricks, and specifically in this one, I would split this fraction up. Put the x squared over x and the minus 4 over x. And then I'd probably reduce these. And I'm just delaying the calculus as long as possible because integrating this otherwise just doesn't look real friendly. So this is what I have written at the top of my page. Now, do I need a plus c here? Yeah, either one. You can either do it here or at the end, but you better put it in one. Do I need both though? How come?
Still just some plus c.
Yeah. Like technically there's some unknown number here and there would be some unknown number here, but an unknown number plus an unknown number, we might as well just say we don't know that the number is ones. Those would combine to some other unknown number. But are you guys okay with me integrating both those parts? Okay, so no fancy tricks, just knowing what I wrote down at the top of the page. If there's a constant or if there's more than just an x, as long as there's no chain rule involved. Consider splitting apart your fractions. That avoids u substitution sometimes. But then of course u substitution is going to be a big one. So again, I don't really want to integrate all of these just because, yeah.
Whenever you did x squared over x, wouldn't the x just be on top and it would jump over
Yes, yeah, x over x.
Oh, you're right. I'm just working too sloppy here. This simplifies to x, which integrates as 1/2 x squared minus that stuff. Thank you. Okay, so again, we're not going to actually integrate all of these, but we're going to at least set them up and talk about how it would start to be set up. So in question 4, what would you guess your u to be to do u substitution?
2x plus 5.
Right. It's not really trapped under anything, but it is at the bottom of the denominator. So if you do that, and then you solve for du, we could rewrite this as 1 over u (1/2) du. You guys okay with the u's I'm picking and the substitutions I'm making? Okay, I'm gonna finish this one just because I don't know. I just don't want to do it 9 times. So I get 1/2. Integrating this would be the natural log of the absolute value of u plus the c. So it's not that it's at that point. I guess the majority of the work's been done, but. Okay, what about u for question 5? Okay, so if we pick that, and then we did the derivative and solve for du, which I usually do in 2 steps, but I'm multiplying the dx over right away to make it out in 1 step. Look at what I have. I just want 1x dx. So if we rewrote this, this would be like 1 over u, and we would need a 1/2 du. But to do the integration, you would need the logarithmic integration. Okay, and let's just pick it up a little bit here because I'm just going for a little bit of repetition. What do you think might be u in this question? Okay, just pick one.
6.
Yeah.
X 4 plus 3x.
Okay. It's okay to pick the wrong one because when you solve for du, if it's not a good fit for the rest of the stuff, then you need to pick a different u. So all of this would be like, how would I rewrite this in terms of u?
1 over
Du. And I said we weren't going to integrate, but I'm going to go ahead and integrate this one. If you know the rule and you plug back in your u, it just takes 2 seconds. But it's a rule you need to know. Okay, so looking at number 7, does it look like the derivative of the numerator gives me the denominator, or the derivative of the denominator is closer to the numerator? Okay, so that's probably what I would pick out for u. And du would be 3x squared plus 6x plus 9, multiply the dx over. Well, that's not exactly what I need. What is this other stuff? How close is it to this? All of it? Yeah, if you divided everything by 3, it would leave behind the other stuff. So in place of 1/3 du instead of all of that dx. So I'm trying to get 3 things here. One is I'm reminding you of the property that we talked about at the top of the page. 2, I'm giving just a touch more practice on picking out u and seeing why it fits. And 3, I think this might be the first time you've seen where sometimes your u would be your denominator. Just that when it is, you're probably going to need some kind of logarithm in your answer. And actually, we can finish any of these that you guys are curious about. Okay, somebody else pick something for u and number 8, please. Okay, so natural log of x, and then if I take the derivative, what's the derivative of natural log of x? 1 over x. We wrote that at the top of the page too, and I can put that back up before we move on. So if we rewrite this, what is it going to look like with u's instead of x's?
U squared.
U squared. What about the 1 over x dx? Right, it's a perfect fit. 1 over x dx is already du. And again, you're not finished, but that's the hard part. You still need to integrate, raise the power by 1, divide by the new power, and then plug that back in for u, and add a c. when we do that, by the way, I'm not sure that you are that interested in it, but when we always say add C, in theory you can even put subtract C, right? Adding an unknown number is the same thing as subtracting some other unknown number, right? It makes that C opposite of whatever it was, but we don't even know what it was anyway, so who really cares? So there's actually one of the calculus people, one of the more famous calculus people that I'm going to ask you guys to watch one of his videos before the AP exam to see if you think it's useful in case you want to watch more of them. But he always does minus C instead of plus C, and he just tells the students that it's a little bit faster to write than doing plus because you have to make one less mark. So that's his argument for minus C instead of plus C. Okay, two more. There's supposed to be a T here, so in this question, I'm going to go the wrong direction for just a second. Let's say I thought this was my U, then du would be this, and that doesn't look anything like this. Like, I guess there's a sign, but there's not a 1 plus, and then this is in the numerator, not the denominator. It's okay to pick the wrong U. Sometimes you guys spend too much time trying to pick out U. Pick something, find a U, and if it's a good fit, it's going to look pretty close, if not the exact same thing. Okay, good with that one? Okay, last one. Let's pick U to be this. Now this is not one we use very often, but technically you're still on the hook for it. What's the derivative of secant?
Secant tangent.
Secant tangent, and if you weren't sure, you could maybe guess it just based on what's left over there. So all of this becomes what? How would we rewrite that? All of this is du. Did you say u du? 1 over u. Good. There's still stuff up there. 1 over u. Which again, I didn't integrate them in all these questions. I'm happy to integrate any of them for you if you need to. But once you get it to look like this, you just need to know that one property. Like that. And plug it back in. Unless you have bounds. So if you know that property at the top of this page, I feel like this handout may be not super necessary, but it didn't hurt for y'all to see a couple like this.
This is on the test too?
Yes, I would expect. Well, U substitution will be on the test multiple times. I would not be surprised if 1 or 2 of them were not this type of U substitution. So with that in mind, any of these you want me to go back over or talk about or actually finish? I put these properties back on the top of the page. Is that helpful, or could y'all have done that anyway? It is helpful? Good. Okay, we got 10 minutes. Let's see what's next. Okay, I'm going to pass back your 5-1, 5-4 quizzes. Now, these are secure, which means some of these questions can't leave the room, not just because of us, but because of College Board. So there's specifically 2 questions I want to talk about, but you should look over yours as well and see if you got something else you want to ask about. And we'll just focus on multiple choice first. Or you can be afterthought. is going over one specific FRQ and only half the people got that one. So I will need you back. You are more than welcome on a separate sheet of paper to copy down the mistakes you made, the things you wish you had known, the formulas you didn't do. But you can't copy down or take pictures of these questions. Again, these are. What?
It's so bad. That's all. I actually didn't do that bad on this one. The second one, I threw the wrong No, I never. I told you I got a 70, yeah, when I calculated it out in my head, it was a 70, that was a 60.
Okay, so one of the multiple choice that everybody had, it could be a different place. Your answer could be different. But one answer, or one question that was by far missed too much for the strategies you could have had was this one. So find this one. Now, if you got this one right, and you're sure you didn't just guess it correct, you're welcome to look at a different question, but I want you to find this one and let's focus on it first. This was not the most missed question by far, but it's just an easy fix if this is one you did miss. So first off, I really feel like you should know -3 should be part of your answer. Why does -3 have to be one of your answers?
Because the lower bound is -3. So that's 0 because it doesn't go 0.
Right, and you're going to hear me say this a few times today. If you think of this as area under the curve, if you start at -3 and end at -3, it's not opening up at all, so you're not creating any area. Does that make sense? If this and this are the same, there can't be any area because it's not opening up. Well, if you didn't know that, you could still get this question right. What else could you have done?
I worked out the whole thing before I realized. Oh, wait.
Now, by work it out, do you mean that you integrated this,
Yeah.
Yeah.
plugged in K the first
Yeah, that's
time?
fine.
Yeah, and then plug in -3. And then just solve for K.
I'm going to put the 1/3 out front so I don't have to deal with it twice.
Yeah, that's fine.
Okay, and you can do that, and you could solve for K, that's fine. Also, since it's multiple choice, what else could you have done?
Plug in
Yeah, you could have tried plugging in 3, see if it comes out to be 0. Like this isn't a long integration, right? I did this in 2 seconds. Integrating x squared takes 2 seconds. So if you want to try at 3 and see if it gives you 0, to realize that that's not part of your answer, you want to plug in 0, integrate to see that that's not part of your answer, you could just do process of elimination, and there's nothing wrong with that. But I've got one more way I want y'all to think about it. It doesn't help on every question, but on this one. How do you sometimes visualize integration? What have I been saying a million times?
Area under the curve.
Okay, well, do you know what this function looks like?
Problem.
Right? That's what x squared looks like. Well, if I start at -3, if I go to -3, it doesn't open up at all, so -3 is an answer. But if you think it goes to 0, look at all this area. That's not 0. If you think it goes to positive 3, that would be all of this area. Is that area 0? Of course not. So sometimes visualizing, hey, I know what this looks like. And the most common wrong answer, I think, was probably both of these, negative 3 and 3. But you know what that graph looks like. You can visualize that that doesn't have 0 area, or you can literally plug it in and see that it doesn't give you 0. Or you can even just work it out, keep up with your k, and then in the end get an equation that you could solve for k. You guys had lots of options there. So again, it wasn't the most missed question, but I just feel like you had so many ways you could have approached that one that that one should not be missed too much.
Is the test going to be more use substitution and like these kind of problems?
Multiple choice is probably about 50-50.
Okay.
I mean, that's very good if you're comfortable with use substitution, and it's very bad if you're not.
Okay, good. Because I'm not good at this. Yeah.
Okay, we got about 2 minutes till lunch, so if you guys would look over your stuff, it's kind of a good stopping place for now. Again, do not leave class with these. I have to have these back. You cannot take pictures of your questions. You cannot copy down exactly the same. But you are welcome to write down the things that you didn't do correct or you forgot to learn from. And I've got one more that I want to do after lunch, and then actually I take that back. 2 more I want to do after lunch, but then plus whatever y'all would like.
Yeah. But half of the ones we're not doing.
Yes, I will.
Where did you go? I thought she was going to say about it again. No, but Shasha almost started walking, and I got nervous. I didn't want to leave them. I told Shasha I'm going to take her to Red Kite because they have the best chocolate croissants. And I want to know if they taste like the French croissants. I never had sticker. You didn't get a sticker, Emily. This is it. You didn't get a sticker. See, why did you had the right word?
I had it right, and then I just couldn't do that in my head. What's yours?
The answer was like 1/3.
Yeah, but how do I know what number 2 is times
It's
2 over
Well, no, you know
7?
you plug it in there.
I don't think you did it right.
What?
He
He said it was look.
No, I did.
I just didn't know.
And then I did.
Because this is 1, it's just 2/3.
9. But I had to plug it into like 9.
Because 1 to any power is 1. And then you times it, so it's just 2/3. So it's just 2/3 minus 2/3. Wait. Yeah, I don't think, no wait. I don't know if she did.
All right, there's 2 more of these I'd like to talk about for sure, and then I'll give you guys some time to look it over a little bit more, and I can help more individually unless there's very common questions. So one of them was F was some integral, and you were supposed to find the derivative of that. Again, not nowhere near the most missed question, but this is by far probably the easiest one. Maybe the one we did before lunch was easier, I don't know, as far as like what you needed to do. This one, this is the second fundamental theorem of calculus, and if you guys remember on our agenda the day before the test, I recommended a few things besides your review to look at. One of them was when we went over these questions, because this type of question was when we did like 10 book problems in 5 minutes. It was super easy, super quick, But I also warned y'all, because students don't struggle with it, they usually don't put much thought into it, and then they can miss it pretty easily. So all you had to do on this one is apply the second fundamental theorem of calculus, which just says if you integrate, or I'm sorry, if you take the derivative of an integral, as long as this is a constant, then this guy just gets plugged in. X squared to the third becomes x to the sixth. And then there was only one other thing you have to do sometimes, which is chain rule. If the derivative of the upper bound is not 1, you have to multiply by that derivative. So, it's unfortunate if you missed that, but that's an easy fix. And the fact that I'm not giving any hints here, I don't know, honestly, but it's a very important topic. Second fundamental theorem of calculus. You should hope that this type of question ends up on the chapter 5, because that's all you have to do. Quicker and pretty reliable. Are you guys okay with this one now? If you forgot the part that's 2x, the chain rule part, you might want to write something about review second fundamental theorem with chain rule. We had a whole handout there. Okay, I didn't actually do any statistics on this, but my gut feeling tells me the most missed question was the piecewise function one. So this is the other one I want to make sure we look at together. And then I will get out of your way and let you look a little bit more. So find where you did this one. Is it exactly this? The other form is a little bit different. I think it's maybe 1x and 1 over x instead of 2.
Yeah.
Okay, but basically the same thing. So here's the first connection y'all had to make. If you're trying to find this, again, my default here is just always phrase it as area under the curve, because that helps you get kind of a visual. If I want to know how much area is there between 0 and e, at some point you have to realize you can't just do that because this is in 2 pieces. You had to split it up into 2 pieces. You could take, again, this is like area from 0 to e. E is just a number. So realize that that's the same thing as the area from 0 to 1 plus the area from what?
1 to e.
1 to e. And why do you think I'm splitting it up like this?
Take the integrate each piece.
But why am I splitting it up at 1?
Because
Right. Because that's when it stops being this one and starts being this one. So the area from 0 to 1, you would have to use this guy, 0 to 1 of 2x, because he's the part of the function that exists when x is less than 1, which would be from 0 to 1. And the area from 1 to e, 1 to e would have to be this part, because it's the part where x is bigger than 1. So understanding this setup and this logic here is by far the most important piece. You guys seen how I split that up? And I had to split it up because it was a piecewise function. But then you can just integrate this, evaluate from 1 to 0, integrate this, evaluate from 1 to e, and what happens when you plug in e? What's the natural log of e? 1. And what's the natural log of 1? 0. It's been a while, but if you guys remember our very, very first quiz of the year, we had y'all review logarithm properties and unit circle. It was for stuff like this, so that you might remember the natural log of e and the natural log of 1. Let's just show up randomly. But I'm less concerned about finishing the question. I'm mostly concerned about this, splitting it up. And again, I just think you're more likely to understand how and why to split it up if you think of it as area under the curve. Some of it came from this, and some of it came from this. But the function was split into two pieces. If you had the other form, I think the answer was 3/2, maybe?
Yeah.
So the numbers are slightly different, but same process. So that might be a good one to practice again. Again, I'm not saying that it's going to be on the chapter 5, but it could be. Very likely to be. Any of these are very likely to be. So I'd like to give you all some time to look over your other multiple choice. I realize some of those are probably just small mistakes, and you can probably figure them out yourself. And then some of them you want to ask about. So let me give you about a 5-minute head start doing that, and then I will come around and help you individually. And then if it looks like I'm getting the same question multiple times, then I'll do it on the board. So.
What number is the mini question today?
87.
Okay, so how did I get the right answer if I set that wrong?
It was positive 1.
Oh, I thought that was a plus. I was in like a, we got that, like plus 1.
Oh, no.
So since it was an FRQ, why did I miss all 3?
For this one, you had to find the critical point, which is like 4.251 or something. That was 1 point. You had to get the value of each of these 3. Oh, you giving me money?
I am. So they're already entered into the spreadsheet with my name as paid, but I just haven't put the,
Okay.
where you have to do your little column.
Okay.
Should be $10.
I know, but making sure it's not counterfeit.
Okay.
Okay. The second point came from using these, like plugging these values in correctly. See, like when x is 0, so that would be at the start. At the start, you had, what did it say? 40 inches of snow. So I'm not sure like what you were plugging that in, but you were plugging those into different things.
Well,
These
I was
values were all-
plugging in the endpoints in the curriculum.
Yeah, I know, but what were you plugging them into?
This function. Whatever, right?
Yeah, but I'm saying something's going wrong there,
Oh,
because if you plugged in 0 here, this should go to 0, and 0 here, this should go to 0. So you should have still ended up with 40.
Yeah.
And then the last point was naming which time and snow was the most.
Okay.
So that's how the points were broken down on that one. Again, we can talk more about the FRQs and stuff tomorrow, but just focus on the multiple choice first. If you feel like you're comfortable with mistakes you made on the multiple choice and you're sure that you're not set to repeat those, then move on to the FRQ. But unless we have a common question that we need to do on the board, you guys are more than welcome to work together on this. You should have similar multiple choice questions. If it's not the same, it should be the same skill.
graph paper?
Do I have any?
Yeah. I can borrow.
You gonna give it back?
No. I mean, I can get that.
Just one?
Yeah.
As I come around, if you'd like a hint on something, then I'd be happy to help. You all done with looking at your tests?
Yes.
Okay, will you put them back in the folder back here? Do you know where they go? No, you don't get to keep it. You don't get to leave the room. Okay. Okay, so you've got a value to start with.
I don't get
The value is 2. Then you've got how it changes. And you want to know the value. Okay, so if you integrate that, if you integrate this through, that will keep up with the change in the function below it. So since this is a derivative, that will keep up with the change of the function. So if you integrate this, what would you want to integrate it from into what x values? 1 to 5, because you know what it is at 1, and you know what it is at 5. So if you do that, the integration will keep up with how it changes over time. And it gives you this answer. But you also started off with 2.
Okay,
So you gotta think of how much you're starting with, plus how it changes. The integration can only do the how it changes part. So my guess, unless you misguessed that one, you probably just math this one. And the binder, one of our searches that we did was average almost all the questions for each of them. The starting value plus integrate the starting value plus the how it changes.
I don't know.
Oh, that's very
Do you know how I got it?
Oh, no, I
Okay, so I drew the graph by plotting a bunch of points, and then
I tried doing that, and then I just had no idea what to do after that.
and then I integrated.
Well, if you want area under a curve, that means integrate.
No, for some reason I integrated 2 and 0. Like 0 and 2, and then and it integrated x 2 minus x. And then I did a 1 to that.
That's because that's the only one that's positive.
Oh, in the first one, yeah.
Okay.
And then I just took the area.
Yeah, I literally wrote a question mark because I just did not know what to do.
Did you get this one on the number 1? Is that what you got?
1 minus x?
X points on this.
Now let us configure like how.
So, what does this look like?
Was yours like the same question though?
I think all of ours are so much.
You did.
Should I just ask like, how many combos? We got it right.
I would say just plug in a couple points. Like if x is 0, what is y?
No, maybe this is right.
If x is 1,
That was a funny picture of me.
No, but you put the 26 points.
So maybe you're right.
Are you sure?
Why did everyone like run?
Okay. And if the parabola it opens down.
Like while they're
Because the continuous function.
Like while they're shaking hands.
Yeah.
The continuous function,
So you're trying to find that.
Yeah, yeah.
So it looks like you're trying to integrate from 1 or 0 to 1. I don't even remember what it is. You have to put.
what answer did you get?
You have 13
I tend to go to the graph. It's like.
Yeah, you did one wrong.
I was like really confident about that one too.
Yeah, I literally don't even.
Did you get this one?
No, I
Oh, no, I got that one.
I mean, I just.
What'd you put?
I just
I got
forget
that.
to
A little.
Well, it's only because I like.
So it should be 26?
Yeah.
Do you know where to put it back? Control. I'm not gonna say.
Yeah. We'll try that.
How do you tell us that?
I think I did work it out, and that's like the 26.
A lot of effort here is
Divided by 2 or something.
No, I think
You
the
get
best
it.
didn't work maybe.
So this one was the to divide by.
So for
Use
part
or?
one,
Yeah.
so you wanna know if
You're just
speed
like
is
a-
increasing,
It's not really
That's the thing that we talked about where you need to check velocity and acceleration and see if the signs are the same.
I just.
So if you plug them into both, they were either, I think they were both negatives. So just they were both negatives.
So you took the easy derivative of that, right?
I don't know.
Okay. How do you?
How do you do this one?
I went over that one when you went over that.
What we did? Okay, I was going to say.
Oh.
I was looking at how did I
Okay.
Okay, so you know one value.
No, I-
What is the value?
It's like the.
Okay, which one of those numbers is the value?
The one that doesn't have another
Okay, so
head.
you've got 2
Right.
at time equals 1.
Yeah.
Okay,
I
how
just
can we
remember
keep up with how
I
it
didn't even
changes
look it
from
up.
x equals 1 to x equals 5?
And you can do like that integrate bounds from 0 to 5.
I'm sad that
Or
we
1 to
can't
5.
do it.
Why 1 to 5 and not 0 to 5?
Okay, you start one. And then you add 2 to like that.
That's funny.
So
Oh.
2 plus how it changes.
How did I not even?
So 2 plus integrate 1 to 5 of that mess in your calculator. In your calculator question.
Oh, see what I did? Yeah.
Okay, see, I circled that, which is right, right?
No, but you didn't stick with it.
I know, but that makes me so mad. Like, what made me think that it was that?
I didn't even know how to do that.
No.
I don't even know.
I don't know either.
I thought maybe
just
you divided by
guessed.
2, I don't know. But we did, what I would recommend is one of our circuits we did, like almost every one of the questions was like this. Starting value plus integrate keeps up with how it changes. Starting value plus integrate how it changes.
The form kept changing. So it didn't look the same.
Well, I was just saying, I would look back at that circuit if I was you and make sure that you see the connection.
Yeah.
Because if you don't, then we can talk about it more.
I remember that. Okay, and then this. So like, what was I supposed to do here? This was right, right? Like T.
That was one of them. How did you
But
get that?
I plugged into my calculator, I guess.
Really?
But what did you plug into your calculator?
I think I plugged this in.
Well, you can
Well, I
plug
don't-
in equations.
Maybe I used equation. I don't know. Cause like, was
I think
that?
you probably did, but you're not writing it down. What is I don't wanna go over all of these,
Yeah,
just
there's
because I
a
can't have others. But you have velocity, and this is talking about speed. How do those two compare?
Velocity.
You doing the video?
No, velocity is the one that's like negative and positive. Like has direction like that in space.
So if speed could be 2, velocity could be
Negative 2.
4. If you wrote that down, that was a point.
Or if you showed that you did that.
Oh, no,
Like, really? That's the difference between speed and velocity.
Yeah, I know.
You can make it
Velocity,
Speed
but I
is
wouldn't
always
have, like,
positive. Speed doesn't have
Yes.
direction.
I like
Velocity can be negative.
positive or
So if I say the speed of something is 2 or 50 miles per hour, velocity could be positive 50 miles per hour or negative 50 miles per hour. Your speed's still 50.
So the answer is positive or negative?
Now, there was one point, if you showed that you tried to figure out where it equals 2 and negative 2. With your calculator, just like you solved this, I think probably one equals 2. You also need to solve one equals negative 2. That's what the other one does.
Oh, yeah, I know.
So I'm saying you're losing 2 points there for just one thing. There's one thing you can think about. Does that make sense? I would write that, well, you didn't ever show me that you knew 2 or negative 2.
Well, I showed it could be 2.
Yeah, but that's not what you got the point for. You
Yeah,
had to do
because it was
both.
all values.
Yeah.
So,
But that's something to look at.
Oh, jeez.
Make sure you know how speed and velocity are similar but different. Let's see if there's one other. And you might make sure you get it like you should have. Okay, and then let me help you with one more part, and I'll come back to that. This is great to know the position of time equals 5. In fact, that's exactly what you didn't do right here. But the reason why you got this point, but there was one other point, because it asked for something else. It wanted you to give the equation S of E. You only gave S of 5. It asked for 2 things. Does that make sense?
So.
S of T would be this exact same thing, but not 0 to 5, it would be 0 to T, because it could be any time, not just at 5. What you wrote down is only true at exactly T equals 5. So they wanted 2 things, S of T and S of 5. That's why those points.
Okay.
I just feel like about
Yeah, I just didn't study. I think you explained. This is the one that I can't remember how to do. But I should study this stuff for how to do it all. But I went back and fixed this. Yes. So, it makes sense.
I mean, multiple choice though. I'm more focused on multiple choice.
I don't think I got wrong. This one, you explained that.
Okay.
Up there, and then.
hold on.
Okay, y'all are welcome to link this to the top though, but when you're done, please put it back there.
So this would actually be the T0.
I had a question.
1/6 times 4 over 3.
So with the average rate of water flow, that's derivative of slight, I should be taking derivative of this.
If you integrate all of this, that tells you how it added over time, so that's a total amount of water.
Oh.
If you integrate this from 0 to 4, you would know how much total water you lost. So if you want the average amount, you would divide it by 4.
Okay. So I just took the overall integration, I guess, or like an integration.
What you have written down there is great, but did you try to integrate it by hand or do you go with the calculator?
I'll probably do it. I don't know.
Then
The way that you just sent me was so funny.
you might try typing that in the calculator again, because this should give you the total amount, and then divide by 4 to get the average amount.
Does it matter like which mode it's in?
Only matters that it's in rating mode if you don't have a function like sine, cosine, tangent.
Okay.
But you should just leave it in rating mode all the time, so you don't forget about it. So that would matter maybe, oh, maybe not.
Because you have the velocity equation.
I'll try typing it.
It could mess you up down here because there was a line there. Y'all see something really quick I can help function right now?
Versus hypocrites.
I don't think so. Are you done looking at your quiz? Put it back there in the folder that has your name on it. One of those bins is for time code. And that way you can get it back home. Okay.
Our teacher?
You see my life.
I was so confused.
No, I can't focus. I sit next to you. We need to smell this.
I need some help.
I'm coming.
I thought you were just gonna keep on.
When we talk about the area under the curve, we're talking about the area from the function to the x-axis. If this area is 5, well, right here, I'm sorry. When we talk about the area under the curve, we're talking about from the function to the x-axis. We always draw this. So that's always just understood. But on some questions like this one, if we don't put it, if we said, what's the area under that curve? Well, it goes on forever, so the area would be infinite. You gotta have something that traps the area in. I don't think you need a graph at all on that one. You wanna know the area under this from -2 to 4. So integrate this from -2 to 4.
Use your calculator.
Yeah. Did I do this right? Is this a use
I
substitution?
mean, I guess you can right now, but you may have to do it by hand on the test.
Is this a use substitution question? Because I tried to do it, use substitution, and I don't know if we did it correct at all.
Yes, because this is really close to this.
Yeah. So divided by 4 is
Because
3.
the cube root of x is the same thing as x to the 1/3. So you need to replace it with,
du.
I don't think it's 4/3, I think it would be 3/4.
Oh.
Because you want it to go away.
No. Okay.
But like this one and this one, you'll need a calculator on.
For sure.
Use substitution's not gonna work on this. This is one of those questions that you can do by hand theoretically, but will never make you.
Yeah, I was really struggling.
You have to put thought into when it's positive and when it's negative.
Okay, that makes sense.
I would just do it by hand.
And then would this one be a logarithm one? Since it's
There's a trig function that we take the derivative of to get secant squared.
Is it tangent? Is it just tangent or tangent squared?
Just derivative of tangent is secant squared.
Okay.
But you either need to undo chain rule in your head or do use substitution so you don't have to do the chain rule.
Okay, well I'm gonna do use substitution.
The way you have this rim button, so you put DC at the end here, so you make it here, that means you're integrating all of this. You're not really integrating 40. 40 is like your value that you started with. Plus 40 on the outside of it.
It's what?
The fact that you considered it, I could give you a point. But that was the issue there. This has to go here, because here, if you wanna write this as one big figure, you can, but this shouldn't have been part of the demonstration.
Oh my god, I left my roommate on the letter.
You needed to find a critical number for one of the points, you had to find all 3 values. Like I know this one's right.
Yeah.
You had to find all 3 of the values. Thomas and then you figure out what one gave you.
Oh, yeah. Good. We'll get out at like 5:30.
You might want to actually try that. You also should have one today.
Okay, go look inside of this.
How many like actual pointers?
I mean, actual points like raw score. I need one for multiple
Basically,
equations,
this
9
process is
for
everything we're outside.
then we curve it and scale it.
Whether it's all people or.
Yeah, but if we do really good on the because I was like, if we get like a 90 on the test, I think there is really optimal. So I'm gonna be saying
I will too, but I still think
I'm pretty sure I've heard
because
about it.
always gonna do some like that function. Like we've never done.
I see you're really good.
Just like really expects you to know how they do it.
I would do it like
What
what you have to do is like think of this graph.
are you looking at?
To the top one, like equals 5 looks like. And then you can find this area of painting, like the area from where it's better or worse.
We get President's Day off.
-7 here, whatever that is, you could find that area that they were positive. Then you could find this area, whatever it is, the reason. And add that together. Again, you can see that. You basically have to take the area that's positive, leave it positive, take the area that's negative, make it positive. Basically, if you have your packet, one of those, it's always you should integrate absolute value to get the answer. And then where you go.
I'll answer all my stuff.
I just started like I didn't know cheese. I used to eat lots of cheese.
Mr.
That's right, you're in a social media class.
You just simplify by 4. You still didn't do the average.
Oh.
This gives you the total, but if you want to average, you have to divide by how many parts there are.
I was well mine. I tried to stop that from keep that stuff in doing it, so that wasn't gonna happen.
Happy, I didn't get on my quiz.
I understood that got A, but I didn't got C.
Emily's mad at me. She's not being nice to me today.
No, she's never nice to me, so.
I had the which I still messed up. One of the questions on it was
I'm just missing away today.
Now, I don't mind if you guys look at your quiz again tomorrow, but remember you can also come in anytime during advisory to come and look at them. The only thing that you ever have to wait on is for people to make them up. But if you think you're going to want to look at your quiz a lot more, you might come in during advisory tomorrow. Also remember, well, I'll see you tomorrow because it's a B week, so we get a little bit more practice in. But then our test is on Tuesday. That's my Valentine's Day gift to you. But remember, it can also, this is the only grade replacement we offer this semester. If you make, this is the third time I've been telling y'all. If you make 100 on the Chapter 5 test, you get 100 on the Chapter 5 test, and we will rewrite your 5-1, 5-4 quiz to 100 too.
But it has to be exactly the same.
No, if it's better, we will
Oh,
replace
it's
it.
just better, okay. Because I get all these saying it had to be 100.
I've told you guys this multiple times already.
I know you said
Not
about
when you get
I thought you said 100.
No, but he was using it as an example. Doing that better.
Yeah, that's what I thought. I was like,
It's over the same stuff plus a little bit more, so it's representative of the same content.
I think that's
So that's why we allow.
You skipped through that video. Yes, you do.
Where you gonna be?
You get to see me tomorrow, bright and early. Yeah. 10 o'clock. Because they're waiting on water. 11:05. Okay.
Okay, I get it for you.
It is to me. Me too.
How much did you probably I'm just automatically looking at
Okay, we're gonna do this circuit to make sure we have the difference between these things down. It's a pretty short one. You need your calculator on it.
We take seniors though.
And then I'll take more questions from like the review, more time to look over the quiz, stuff like that. But that's the only handout that you need.
Do you have any extra credit?
86, like 5.
Oh,
Nothing I can know if I would decide is you can do.
I'm gonna give you a test. Even if I wanted to, I couldn't. We gotta do the same thing in all calculus. Will you put it in your folder back there? There's one that's for calculus. There'll be one with your name on it.